Okay, I'm Mikael Lind from gogoNET, and I'm going to follow up on what the previous speakers were talking about regarding CPEs, and CPEs being an issue or a solution for IPv6. So what I mean with a home CPE is the thing that sits between you and the internet. So it could be your cable modem, your DSL modem, or your home router, or both of them, in something, or a combination of both, because sometimes they are the same box. And today, this is the blocking point. Even if an operator can upgrade their network to do IPv6 all the way out in the edge, they won't get into your home, because your home router does IPv4 and only private IPv4. That's it. The issue today is also, I mean, even if you go out and buy this box, it's not going to have v6. There are some exceptions, but the standards and functionality and so on are not mature enough for you to get a box that actually works. And that's the big issue, because no one really knows how it's going to be deployed. And today we're sitting on, I don't know how many hundreds of millions of these kind of devices out there that needs to be upgraded to do v6. So this is going to be one of the big cost issues for doing IPv6 today. So as I mentioned, there are more or less two types of home CPEs. There are the purely layer 2 devices, which are your usually cable modems today, and in some cases your DSL modems as well. In that case, it's okay. That box we don't have really to care about. It's fine. It's going to sit there and do whatever. Another big issue is finding it to configure it. Today we use 192.168.1.1 or something like that. It's a well-defined address on the box that you can go to and access the web interface. But in IPv6, we don't really have that as an option. We don't have private addresses. So should we use the unique local addresses and somehow print that on the box so each box has a unique local private address, or how should we manage it? That's also a big question. And today, if you go out to buy a box, it won't have anything like that. You have to rely on IPv4 to configure it. So you still need IPv4 to use it. There are other issues like address management. I mean, some operators like to change address for you on IPv4 just for the heck of it. If they do that on IPv6, it's a bit different. So suddenly it's going to change on your computer. And the home router has to take care of it, because it's your prefix on the inside is going to change. So how would a home router manage that? So this is also a big issue and something we won't see an answer to until it's actually deployed, I think. And as I mentioned, what about transition mechanisms? What do you need to support? It's not about just supporting IPv6. You need to be compatible with different scenarios. So you might be able to do 6RD in a network where that's available. Or you might have to do DS Lite because the network you plug into is IPv6 only. So you need to provide v4 support. So all the transition mechanisms become an important part of how you build a home router. And on top of that, we have many, many other issues as well. The ITF is working on this now. So it's not like an unknown issue. It's a known issue. We know this is a problem, but we're fairly at early stage still in resolving this. I mean, there are suggestions for what to do with local addresses, security, and so on. But how would it look in the real world? That's the big remaining issue, or question, rather. Whatever they standardize right now is to have a starting point, but we don't know what the operator is going to deploy. And we don't really know what people want to expect out of their box at home. So we won't have the real answer until we get some real deployments. But this is a good starting point, at least, to have like a basic spec on this is how you probably should build it, or at least have this kind of functionality in it, or something similar. Well, a home CPE doesn't have to be all bad. It could also be good, as the previous speakers have mentioned. It could be the tool for you to enable IPv6. So instead of being the blocking point, it could be the thing that actually makes it possible for you to get IPv6 into your home. And that could be using many different technologies that are available out there. Usually different types of tunneling is the big thing today. I mean, to get IPv6 out, we want to get v6 there. But the next step is going to be, when we're past the depletion point of IPv4, it's going to be about how to continue running IPv4 networks. So we have DS Lite and so on. And what a functioning home router, there is nothing. So the home router is extremely important. So what we have seen so far is, and as we mentioned earlier already, is deployments using 6RD. When it has been operators that can manage their modems or home routers, and Free in France upgraded their modems and added 6RD to them, and suddenly had a few 100,000 IPv6 enabled customers. The reason for using a CPE to do something like this is because the access is usually the hardest part for an operator. So depending on type of network and so on, it is where they're going to run into most of the issues, getting it all the way out to the edge. So the home router is the worst thing because it's blocking it completely. But if you can fix the home router, you can use it to bridge your access network. And that's where the cost is today, in the home and in the access. The core is already done, more or less. And as Alain described, is the reverse case, where we do DS Lite or something similar, like TSP, to tunnel IPv4 over IPv6 out to a box that is likely going to be a NAT box to share addresses, or just be a tunnel endpoint if you pay enough money to your operator, because then you're going to get your address anyway. And for the end user, or for most end users, this is going to be exactly the same as what they had before. They have their home router, they get a private address, looks and feels as it does today, with the added benefit of IPv6. There are products, as I mentioned, out on the market today. Support varies from specific model to model, so it's hard to say exactly what's out there. Draytech, for example, is a company that had DSL modems out on the market a long time ago and still has with IPv6 support. That uses different types of tunneling, but also can do native. Zyxel has modems, but still in more beta stage, as I understand it. 2Wire say they have IPv6 capable modems. What that means, I'm not sure. But it at least does some IPv6. On the home router or the NAT boxes, D-Link actually has official support for IPv6 on some products, like the 615 home router, for example, is officially supported as an IPv6 product. Apple used to be the big source of 64 traffic because they had it enabled. They used to be the only ones who actually enabled 64 on the router. Unfortunately, they don't do it anymore. But they don't support v6 as a support. I mean, it's not a supported protocol on the box. So if you have problems, it's your problem. There are some other, like Buffalo and some other minor manufacturers that do have IPv6 support today. But in all these cases, It's not like you can plug it into a network and get it working, because their support is more, you can configure static tunnels, you can use 6 to 4, and you can use it connected to a native network if you manually configure it. There's no automatic configuration on these boxes. So it's limited, but you can use it today. The best bet right now is probably to get a box and put OpenWRT on it, because that's where you have most features today. And gogo6 ourselves, we have a different take on it, which is an upgrade to existing home routers, which is just an IPv6 home router with tunneling. So instead of replacing the boxes, you add on this mini router that does the IPv6 part, but none of the IPv4 parts. It does it in different flavors, like in TSP, which is v6 in v4, or v6 in UDP v4 tunnels, or 6RD, or L2TP, for that matter. But it also comes in a 2-port version to let you keep your old IPv4 router and stay in IPv4 when your operator moves to IPv6. So then it becomes your DS Lite router or your DSTM router that gives you IPv4 to your existing network. You can leave it as is. You don't have to care. Your own route works fine, and the operator can move on to deploying its new network. That was all I had about CPEs. Questions? They're not free. Right now, they're actually about $100 each, but these are like early production units, so it's small volumes as is right now. Okay, now I know there's some Linksys more on the enterprise side that I support, but I haven't seen any. Okay, yeah, there are some models here, and they're popping up right now, but so as far as I've seen, it's very few that has official support. D-Link is one of the few ones that say they officially support it. Okay. That one as well. Okay, that's nice. Yeah, things are starting to happen when it comes to home routers. More and more vendors are adding the support, but I think the big issue for real deployments is still that they're not fully capable. They can do v6, but they need some help to actually do v6. Okay, thank you. Oh, there was one more. Yeah, this is, I mean, intended, this device is intended for home use. I mean, that's the thing, to take care of the cases when you have existing equipment, you have people who don't want to change their equipment and so on. So it's a way of working around the legacy equipment issues in the home. Yeah. Yes. Yes. Yeah, I mean, the Juniper one doesn't have anything right now. It is the server end of it. You need the server end, and you need the home router end. No, these are a complement. You need the Juniper box to be able to use this box, because that's going to terminate the traffic in the operator's network. So for the operator, it's a question of having the server side of it and being able to manage the home end of it. So it's going to be a multitude. There's not one solution that fits all. It's more a question of finding a set of different home routers to solve the different cases of users they have. But technology-wise, it's the same thing. So they're going to work together, both as a client-server model, more or less.
So what is the Gogo CPE doing differently about its IPv6 tunnels and things that work with NAT, where most other CPEs don't? Or is that special? Is it just some standard, or is it some secret sauce?
It's a standard protocol. It's just that it supports UDP tunneling versus just V6 and V4 tunneling. So it has a NAT detection function in the tunnel setup. So if you compare it to 6RD, for example, which is more of a stateless protocol, the issue with that one is that it needs a public IP to work. The benefit of it is it's stateless, and you can run it peer-to-peer within a network. When you do the other types of tunneling, like TSP or L2TP, you're doing a stateful tunnel. So you're doing a connection, but that means also that you can punch a hole through a NAT. So you can either set it up as the same type of tunneling or encapsulation as 6RD if you have a public IP, or you put everything in UDP if you're behind a NAT, and that allows you to punch a hole straight through the NAT and get out and get IPv6. Did you have another question? Yeah, for the enterprise, I mean, it's the same thing. It might be a different type of device, not like this form factor, but from a functionality standpoint, it could be exactly the same thing. You probably would have a different type of router that you would use, I mean, but the actual underlying protocols and functions would still be the same. No, I mean, not that I know of, at least. I mean, it's more a question, is your operator going to sponsor you in getting a new device? Or will you have to go out and buy it yourself? So I think it's more that kind of a question. So is it going to be included from your operator, or you have to go buy it yourself? They were from, I mean, that was the government paying for it, so.
Right. So, I mean, you know, is it worthwhile looking into a similar program for this type?
I mean, sure, but I don't think that would be a solution. I don't think it would ever happen, really, because today we're already getting these kind of boxes sometimes and from the operators and sometimes not. And this is just going to be a continuation on it to some extent. Okay, thank you.